In example 5, we're finding the derivative. It's given to us in this notation, d over dx, of this function. And what I see here is a chain rule with a quotient inside, and inside the quotient there's another chain rule. Now I could use u substitution, but this is a really long, complicated problem. The best way and easiest way is to use your log properties from algebra. So let's remember those log properties. We've got the log of a product is the sum of two logs. So if you're multiplying two things inside, you can split it into log A plus log B. The log of a quotient is the difference of two logs, so we can split that into log of the top minus log of the bottom. And then a log to a power, you can move the power in front, so it's x times natural log A. So what I see here are these two properties that I drew arrows to. I see a quotient property, so I'm going to split this into log of the top minus log of the bottom. And I also see an exponent property. I see that the square root is really a 1/2, so I can put a 1/2 in front of the log. So the first thing I'm going to do is split this and expand it out using algebra. So it would be natural log of the top minus, now I'm going to do natural log of the bottom, and on the bottom this has an exponent of 1/2, so I can just pull that in front. 1/2 natural log of x minus 2. So again, I just split the division with subtraction, log top minus log bottom, and then the square root is a power of 1/2, and you can pull that in front of the log. And now I find my derivative. So the derivative of natural log x plus 1 would be 1 over x plus 1 times the derivative of x plus 1, which is 1. So you don't need that. Minus, there's a constant, you can leave it in front. Then you do derivative of natural log x minus 2, so that would be 1 over x minus 2 times derivative of the inside, x minus 2, which is just 1. So again, it doesn't matter. And then you can decide how you want to simplify that. So I guess what I would do is get common denominators so I can subtract these fractions together. So if I give this one a 2 and an x minus 2, then I would have that common denominator. Minus, I would give this one an x plus 1 and get that common denominator. And then here I would distribute my 2 and distribute my negative and subtract these fractions together. So that's going to be 2x minus 1x, which is x. And it would be negative 4 minus 1, which is negative 5. And then you've got your common denominator, and that really is as simplified as I would take this.